Hey beautiful people, welcome back to my channel. My name is Busisiwe Dlamini Harodi, the K-Path principal. I'm back again with another video. In this video, we are going to do dilutions. So what are dilutions? So because of the word shin, so we know that this is a process. So it's basically a process of reducing a concentration of an analyte or of a solid by adding more solvent. And usually a dilution, when we talk about a dilution, it represents a part of a solid and parts of a solvent. So this is how we would usually represent a dilution. This one basically will represent your solute, and the 10 is going to represent your total volume. Because when you make a dilution, it means you are, in this case, you are adding it's one part of the solute or of the analyte in the total volume of 10. So every time when you read a statement that talks about in a 1 in 10, then you know that is a dilution. Or when you talk about 1 and 9 parts, 1 part and 9 parts, then that together as well, it's going to give you a dilution. So every time when you see a stroke 1 over number or 2 over something, just know that this represents a dilution statement. And also when you see an and in a statement, just know as well that it represents a dilution statement, as well as in and to. So all of this, they will represent a dilution statement. For example, if you get a statement that says make a 1 part of serum in 9 parts of saline. So they say make a solution using 1 part of serum and 9 parts of solvent. So just because there's an and there, automatically we need to think about that this is a dilution. And we know that a dilution is always represented as a 1 part of a solid over a total volume. So in this case, you have 1 part of serum plus 9 parts of solvent, which is 9. So it means the total volume is going to be 10. So if you represent it in a tube, this is your, let's say this is 1 ml of your serum, and then this is your saline, which is 9 ml of saline. So together these two, they give you a total volume of 10. So basically when you add 1 part of serum and 9 parts of solvent in a tube, you are basically making a 1 in 10 dilution. So every time when you see stroke in a statement, in, and when you see an and, automatically think of a dilution statement, because it does happen that most people, they will confuse a ratio statement and a dilution statement. So with dilution, it's the stroke, in and end. And then with the ratio statement, that's when you can say 1 part 2, 9 parts. Then you know in that case you are speaking of a ratio statement. So now let's get to making a dilution, because the reason why we usually learn about dilutions is because in the laboratory there are times whereby we need to make this dilution. And when do we make a dilution? We usually make a dilution if the result of the analyte from the patient sample is above the measuring range of the instrument. Instruments, they get calibrated, and then they will obtain a calibration graph. Then that calibration graph, it's the one that will determine the measuring range that the instrument can be able to read from this lowest number and up to the highest number. So if the analyzed concentration in your patient is higher than the highest point of your calibration curve, then that's when you're going to find a result that comes out of your machine with a greater sign. Then it means whatever result that it's in that or from the patient sample, it's above the measuring range, and in this case you will always have to do a dilution so that you can get a correct number. And after you've done the dilution, we will run that sample as diluted as it is so that the instrument can be able to read it, and then the result that comes out, we will multiply it with a dilution factor so that whatever that we report, it will be representative of what is happening in the patient's body. So what I can advise is that it is always wiser that before you start with your dilutions, you check how much serum do you have. So if this is your patient sample, so obviously this will be your red blood cells, your Buffy code, and then this is your serum. So you'll have to determine how much of serum is there in your patient sample, so that you can be able to determine the volumes that you need to do. Let's say the SOP in your lab, it says when the beta ECG results comes out as greater than, you have to do, let's say, a 1 in 5 dilution. So basically that's what they're saying. You need to do a 1 in 5 dilution. So you know now from our introduction that the 1 in 5, this 1 will represent your part of your serum, and then the 5 will represent the total volume. So now, like I say, you know what dilution you need to make. You determine how much volume is left in your patient sample. Let's say in your patient sample you have a total of 2,000 microliters of serum, and then now you need to do a 1 in 5 dilution. So you can say, okay, if I have 2,000, from 2,000 you can be able to get 100 microliters. So let's say you decide, okay, for my serum, for my part of serum, I'm going to use 100 microliters because my serum, it's more than enough. So I can be able to get 100. So let me try to simplify. This is 1 glass of your, let's say this is your solute, which is your 1 part, plus your solvent. It gives you a total volume. And according to the dilution that we need to do, it means we need to have 1 part of solute and 4 parts of solvent, and our total volume is going to be 5. That's what we got from our dilution statement. So now you have decided that I'm going to use 100 microliters for my serum. So it means for your part of solute, you already have 100 microliters. Now, how are you going to determine how much of the cell line or how much of the solvent must you use so that you can dilute this sample? Then what I would usually do, I will multiply my 1 part of solute by the number of parts that I need of the solvent, which in this case is going to be 4. So it's 100 microliters multiplied by 4. It's going to give me 400 microliters. So it means when I'll be doing my dilution, I'm going to add 100 microliters of my serum and 400 microliters of my cell line, which is my diluent or my solvent, and the total of this is going to give me 100 plus 400 is going to give me 500 microliters. So now let's write this in a dilution statement so that we can see if we'll be able to get our 1 in 5 at the end. So when we have to write this as a dilution statement, we know that the top part, it has to be our solute. And in this case, our solute is 100 microliters, which is over the total, which we said it is 500 microliters. And then now, in this case, what we need to do, we have to simplify this so that we can be able to get a dilution factor. So to simplify it, you say 100 goes once into 100, and 100 goes 5 times into 500. So you see now in practice, if you have to do a 1 in 5 dilution now, I can just pipette 100 microliters of my serum, and then pipette also 400 microliters of my saline to make a 1 in 5 dilution. So basically that's how you would make a dilution in a laboratory practical. So first thing first, if you know how much serum is left in your tube, then now you need to determine in your head, okay, using taking into consideration the pipettes that you have in your lab. Then you will determine the volume that you want to use, and then you can be able to determine the volume of the solvent. Then voila, you have your dilution. So this is what you would usually do in practice. But again, in an examination, you will do find that there are times whereby they can give you a statement and ask you how would you prepare a certain dilution, and then they will give you the total volume. So now they are telling you that at the end you must have let's say a total volume of 2000 microliters. Let's use that example again. So let's say they're telling you prepare a 1 in 10 dilution, and the total volume at the end, it must be 2000 microliters. So in this case, you can't just think on your own and say I'm going to use 100 microliters. So now you need to calculate how much of the solute or how much of the serum you will have to pipette to do, because now they are being specific for you. So make a 1 in 10 dilution, whereby your total volume has to be 2000 microliters. So we can write this like this. We know it's 1/2 total volume, and in this case you are also given a total volume. So you can be able to do ratio and proportion so that you can be able to find how much solute must you use so that you can have that total volume. So your 2000 microliters represent the total volume, and the solute you do not know. So that's what you want to find out. And then you can cross multiply. You're going to have 10x, which is equal to 2000 microliters, divide by 10, divide by 10, because whatever you do on the left hand side, you must do on the right hand side. And then 2000 divided by 10, it is 200 microliters. So it means now for you to do this 1 in 10 dilution and end up having a total volume of 2000 microliters, you need to prepare 200 microliters of your sample. So now it becomes easier because you know the solute, you know the total volume. Now what you need to do is to get the amount of the diluent or the solvent or saline that you will need to use. And we know that solute plus solvent is equals to total volume. Then we can just substitute our solute. We know, we just got it now, it's 200 microliters. The solvent is what we don't know, and then the total volume they gave to us, they said it's 2000 microliters. So in this case, now we're going to take this 200 to the other side of the equal sign, and when it goes to the other side of the equal sign, the sign of this 200 changes, it becomes a negative. Then in this side, you are only left with the solvent. So now the solvent will be equals to 2000 minus 200 microliters, which will give you 1800 microliters. So it means to make this 1 in 10 dilution and end up having 2000 microliters total volume, what you need to do, you're going to prepare 200 microliters of your serum, and also prepared 1800 microliters of your solvent together in a tube. So there is your serum, and then there is your solvent. Then together they give you 2000 microliters. So basically that's what we have done in an exam. So when it comes to dilutions in the laboratory, it's very important to know how to get a dilution factor, because like I said, we will do this dilution if the result is above the measuring range. And then, but mind you, when you run a diluted sample on a machine, the result that you get from the machine, it's not the result that is in the patient. So what you need to do, you need to multiply that result with a dilution factor so that you can be able to report the results that are representing what is happening in a patient serum. And to get a dilution factor, you must always make sure that you write your dilutions in their simplest form. Let's do an example. Let's say you get a question that says, what is a dilution factor if you add 4 ml, if 4 ml of serum is added to 216? If 4 ml of serum is added to 16 ml of saline, then you want to know what is the dilution factor. So let's write this in simplest form. They say, okay, you've added 4 ml serum to, you see, this is a ratio statement because it's not talking about and in, it says 2. So it means you have 4 ml and you're going to have 16 ml because you added this to that, right? And then now what you're going to get, so this is the diluent. The total volume of these two, 4 ml and 16 ml, gives you 20 ml. So now let's write it in a dilution statement. It's going to be 4, because a dilution statement is 1 part of solid over, it's a part of solid over total volume. And the total volume, we say it is 20. But like I said, to get a dilution factor, you always have to write the dilution in its simplest form. So to write it into simplest form, we're going to say 4 into 4 goes once, and then 4 into 20, it goes 5 times. So it means when you are adding 4 ml of serum into 16 ml of saline, you are making a 1 in 5 dilution. And whatever result that you're going to get from this solution, you're going to multiply it by 5 so that we can be able to report the concentration that is in the patient's body. So basically that's what I wanted to share in this video. I'm hoping that everything that I've said makes sense, and I hope to see you in the next video. Bye.